This storyboard is the second of two parts, reflecting the current understanding of FAA subject matter experts of the ICAO Trust Framework, or ITF panel, and may evolve as needed. Welcome to the International Civil Aviation Organization, or ICAO, Trust Framework, or ITF Storyboard, Part 2, Trust Framework Instances in Action. Please watch Part 1, Establishing an ICAO Trust Framework, to learn about the foundational ingredients necessary to establish a robust trust framework. As mentioned in the first storyboard of this series, the ITF represents the ICAO's efforts in developing requirements, guidance, and best practices in order to create a digitally seamless sky and facilitate the exchange of trusted ground-to-ground, air-to-ground, and air-to-air digital information among nations across the globe. This storyboard will demonstrate 3 examples of the ICAO Trust Framework being implemented via Trust Framework Instances, or TFIs. These are Digital Personnel License, or DPL TFI. In prior documentation, at ICAO, the term Electronic Personnel License, or EPL, is used equivalent to DPL. Navigation/Wide Area Augmentation System, or WAAS TFI, and Trajectory-Based Operations, or TBO TFI. The foundational aspects of each TFI are the same. However, the information and purpose of each of these use cases, also known as TFI-specific requirements, vary to meet the needs of the TFI. The end result is the delivery of Trusted Digital Identities, or TDI, and Trusted Digital Information Exchange, or TDIE. Now that we know that digital information should be protected at a level that is aligned with the impact that the compromise of that information could cause, we can understand that not all data is created equal. The confidentiality, integrity, and availability, or CIA, of some data may be more safety critical or sensitive than other types of common data found in the world around us. For example, some information could require advanced levels of security in confidentiality and integrity, but only require basic levels of security for availability. Another piece of information may require an equal intermediate level of security in confidentiality, integrity, and availability. Organizations exchanging digital information must be able to ensure that their information is protected at a level sufficient for the intended operation. Without a trust framework, it may be possible for information to be intercepted and modified unbeknownst to the original sender or final recipient of the information, creating an environment where certificates, licenses, and other official identification or documentation may be forged or falsified. The risk of falsifying digital information or digital licenses without cryptographic protection is actually greater than physical licenses. The underpinnings of these TFIs are all similar, however, each has unique flavors, also known as TFI-specific requirements, to ensure that they meet the need for that particular TFI and the nations involved. A trust framework begins when 2 or more participants, such as civil aviation authorities or CAAs, across the globe determine a need for the exchange of information. This becomes the basis for a new trust framework instance, and so, a Trust Governance Authority, or TGA, will be established. A participant elects a representative to the TGA. The TGA oversees the overall implementation of the trust framework and facilitates collaboration between the participants. Each CAA must also choose an Aviation Common Certificate Policy, or ACCP, compliant certificate authority. The certificate authority acts as the technical entity which issues and signs digital certificates for a participant. A trust framework relies on digital certificates issued by the CAs to authenticate participants' shared information. Participants in a TFI must have network access to the Trust Validation Anchor, or TVA, to verify the authenticity of digital certificates using the trust list, or TL, hosted by the TVA. It is possible for multiple anchors to exist within a single TFI. In fact, two may be necessary for resiliency. The trust list is a digital file hosted and signed by the trust validation anchor. It contains a curated list of trust root certificates representing the Civil Aviation Authorities, or CAAs. There is only one TGA-approved trust list in a TFI, but there can be multiple copies of it hosted and signed by each TVA. The list can be cached regularly by the participants to increase availability. Each certificate authority certificate in the trust list has a URL pointing to the location of a certificate revocation list, or CRL, allowing the participant to validate a certificate's revocation status. The Trust Information List, or TIL, is a list of all the information that participants are exchanging within a TFI. The TIL contains the level of protection for each information type needed or provided for each participant. The level of protection is based on the risk assessment that each participant performs. The TIL allows participants to verify and determine that the information that they are receiving from a participant is interoperable from an operational risk perspective. Now for a look at how the Digital Personnel Licensing, or DPL, Trust Framework Instance functions. In the digital age, managing personnel licensing, including pilot credentials and certifications, is moving away from paper-based systems. With the ICAO Trust Framework, DPL allows for the secure digital issuance, storage, and validation of aviation personnel licenses. As previously mentioned, Digital Personnel Licensing, or DPL, was referred to as EPL in prior ICAO documentation and has since been updated to DPL. This system improves efficiency and reduces fraud, allowing airlines, CAAs, and other stakeholders to quickly validate personnel qualifications in real time. For instance, in the digital personnel use case, a pilot's license is digitally signed by a certificate authority. Inspectors, relying on this system, can validate the pilot's credentials through the TVA. Inspectors and pilots interact through a series of applications. For instance, an Inspectors and Pilots app will automatically connect to the TVA, download the trust list, and the relevant certificate revocation lists. This validation process ensures that the information that they are exchanging is accurate and comes from a trusted source. This information allows the participant to validate the authenticity of the inspector, the pilot, and the license. In the case of the DPL, the inspector and pilot can review the trust list to know if the party is to be trusted. The DPL holder shows their QR code to the inspector to consent license validation. The inspector scans the QR code with a mobile application. The inspectors and license holders' devices perform a mutual authentication using each other's certificates, leveraging peer-to-peer networking using Wi-Fi Aware or Bluetooth. The inspector and license holder certificates are validated leveraging the trust list and certificate revocation lists. Alternatively, the inspector can validate the digital personnel license offline by retrieving the license from the CAA of the pilot. The license holder's device sends the requested digitally signed license information to the inspector's application using an encrypted protocol, ensuring confidentiality and integrity. The inspector's application validates the integrity of the license information using the trust list and certificate revocation lists. The inspector's application displays the license holder's license for license compliance verification by the inspector. Now for a look at how the Navigation/Wide Area Augmentation System, or WAS Trust Framework Instance functions. WAS is essential for improving the accuracy, reliability, and availability of GPS signals across aviation. WAS enables more precise navigation for aircraft, ensuring safety in flight paths and landings, particularly in challenging conditions. The ICAO Trust Framework is critical to ensure the integrity of this data. WAS depends on high-integrity data being transmitted from satellites to ground stations and aircraft. The aircraft radio requires a valid certificate revocation list and a ground station CA certificate obtained from the TVA. The Trust Framework ensures that navigation data remains uncompromised from the source to the user. Through Trusted Validation Anchors, or TVAs, the Trust Framework enables onboard validation that the data coming from WAS satellites has not been tampered with, ensuring safety and reliability for navigation systems. WAS, supported by the ITF, enhances safety while protecting the critical navigation data that aviation depends on. Now for a look at how the Trajectory-Based Operations, or TBO Trust Framework, enables integrity of communications. TBO represents the future of air traffic management, allowing for more efficient, predictable flight paths by implementing four-dimensional trajectories, which account for where the aircraft are and where they will be in the future. The success of TBO relies on seamless data exchange across multiple systems and stakeholders, and the ICAO Trust Framework plays a vital role in making this possible. The trajectory and weather information exchanged from air navigation service providers, or ANSPs, is signed by the originator. The Trust Framework ensures that TBO across different nations and ANSPs can exchange data securely and efficiently. It allows for continuous trajectory updates and management without compromising the integrity of the information. The digital signature, through the TFI, can be authenticated and protects the integrity of the information shared. TBO requires real-time updates on flight paths, weather, and other variables. The Trust Framework safeguards this constant flow of data, enabling that it is secure and trustworthy. By ensuring data integrity, confidentiality, and availability, the ICAO Trust Framework is building a foundation for a safer, more efficient, and globally interconnected aviation system. This storyboard was developed by the Verification and Validation, Strategies and Concept Visualization branch at the William J. Hughes Technical Center for Advanced Aerospace. Thank you for watching.